Hello friends, how are you all? Have you ever wondered that when you are moving over a train and some another train is moving in the opposite direction, then you would have observed that it will seem to be moving with the lightning speed. What happens at all that even though both the trains are moving in the same speed, it will be seem to be in the lightning speed. Let us uncover all this particular science behind the condition and let us explore the part of relative velocity and let the relative velocity explain all these conditions which we experience in our day to day life. Let us start our session today and we are moving with the session of relative velocity. Let us start the session and be ready with your pen and paper so that either of the part of this chapter is not going to be get uncovered. And definitely if you are going to practice well, it will result well. So let us start the session. Here I am Nitesh Ranjan and I am starting the session of this relative motion with you guys. Yes. So one of the lecture of mine is already present on our YouTube channel. You may just go with that particular video. Even though that video is in Hindi, so you will definitely enjoy that session. And if even though you are going to face any of the issues with that particular video, you just drop your query in the comment box so that I will be coming up with the re-explanation part of this topic. Let us start the session and I am now presenting before you the relative motion under gravity. So guys, what happens? Here we are studying about relative motion under gravity. What is motion under gravity? So this is the acceleration which is offered by the earth surface. So definitely this acceleration is nothing but minus g. Why minus? Minus due to the attractive force by earth's surface. So what happens is friends, if we are studying about relative velocity, you could have gone through the last video that we have been seeing the condition that if we are going to observe either of the particle, let us assume one condition. This is A and this one is B. If I am just projecting it up and we are just dropping this object down, what happens that this particular object will go up and this is getting dropped, right? So that way what happens if I am just telling that we need to find out the velocity of A with respect to B. So in that way what we need to do is we are just going to make the condition of that particular frame with respect to which we are finding the velocity into the state of rest. Means what we need to do in a simple language, what we are going to do? We are just going to reverse this particular velocity in the opposite way with the same velocity and we are just going to add it up here. So that way we will be finding the relative velocity. Okay. So let us do the same way. If two of the objects are moving in this way, this one is velocity of A and this one is velocity of B, and if we are very keen to find out the velocity of A with respect to B, what we are going to do? We are just going to reverse this particular direction of velocity of B. We are just reversing it. So obviously prior to reverse, this particular condition was the condition of object B and it was moving with VB, and now I have added it up with minus VB. So the velocity of this particular object will become 0, right friends? And the magnitude or the value by which we are making it 0, we need to just add it up with the another object. So we are just going to add it up with the A object. So A object was already moving with VA and we are adding it up here like this VB. So here VAB will become what? VA minus VB. What I am doing is, friends, we are just, yes, this is VA. This one is VA. I hope you could have understood what I mean to say is VAB will be written as VA minus VB, and same way if I am writing about VBA, then we are just going to do what? VB minus VA. Clear, friends? Very good. So let us observe it here. In motion under gravity, relative acceleration will be written in this way. So what happens? AAB will be written as A of A, means the acceleration of A object with respect to ground minus acceleration of B object with respect to ground. So what will happen? Minus of G minus of minus G. So it will become minus G plus G, it will become 0. So here the relative acceleration becomes 0. Same way VAB will become what? VAG minus VBG, and this way we are just going to write down VAB means the relative velocity of A with respect to B. I hope this particular point is very much clear to all of you guys. So let us move with the next slide, and in that slide we will be coming up with the new concept. So if you wish, then you may just take the screenshot of this slide. Alright, let us move ahead. Okay, one more thing I would like to say is, so if suppose the relative acceleration is, if suppose I am telling the acceleration of A with respect to ground minus acceleration of B with respect to ground is equals to 0. It means what? What does it mean? It means that the relative acceleration is going to be 0. So if suppose A relative is equals to 0, it means what? It means, sir, that in that particular direction the velocity will be constant, right? So if I am telling that the velocity is going to be constant, I mean what? It means what? That the object will be moving in the straight line. It will be moving in the straight line because V relative will definitely be constant, and that way it will be moving in the straight line. So if suppose in any of the cases, if it happens that the relative acceleration becomes 0, then definitely you have to understand the concept. That key concept is what? That two of the object will be moving in a straight line relatively. Alright. So this particular concept we will apply in the upcoming slides, and so that way we will be applying it in the numericals. So let us start with the numericals here. Here it is. Ball A is thrown downward from the top of a building of height 40 meter with a velocity of 10 meter per second. At the same time, another ball B is thrown upward with velocity 30 meter per second. 1 second. These PPT guys have done little bit of mistake. So before you could have said something, I am just rectify the issue and I am just making it correct. Now let us move. Here it is. So they are telling ball A is thrown downward from the top of a building of height 40 meter with a velocity of 10 meter per second. At the same time, another ball B is thrown upward with a velocity 30 meter per second from the base of the building. As shown, find the time and height of ball A from the ground when two balls will collide. Suppose here I am telling that we need to just find out the time. So let me know one thing. If I am just telling that what will be the relative velocity. See, here it is the frame of B, here it is the ground frame. So in the ground frame, what it is happening? This particular object has been projected up with velocity 30 meter per second, and this particular object has been projected downward with the velocity of 10 meter per second, and both are in the same direction. I mean, both are moving in the opposite direction. Alright, what happens that both are under the influence of acceleration due to gravity. So acceleration of A with respect to ground will be minus G, and same way acceleration of B with respect to ground will be minus G. If I am just telling you and if I am asking you that let me know what will be the acceleration of A with respect to B, so you could have understood in the last slide that we need to write down acceleration of A minus acceleration of B, and both should be with respect to ground, with respect to ground. Right, students? Yes. So okay, so that way if I am just writing it down here, we can say that this becomes minus G, and this way this becomes minus G. So if suppose this and this will get cancelled out, and here it is, the acceleration will be 0. If the relative acceleration is 0, guys, so what happens? The relative velocity will be constant and it will be moving in the straight line. It will be moving in the straight line. So what happens? See here. So if I am just doing what? See here, I am just considering with the B frame. So we are making the B frame to be under the state of rest. If suppose, if I am telling what, this particular 10 meter per second, you just need to make it a stop. Sorry, in B frame it is telling. So you need to just make the velocity of B to be get stop. If I am just making it a stop, so by what value I need to add it up? We need to add it up with the minus 30 meter per second value, right?